CIET NCERT presents audiobook Ganit Prakash, Part 2, Textbook of Mathematics for Grade 7.
Chapter number 5, page number 97. Connecting the dots. On the right side of the page, you are provided with a QR code, scanning which you can reach out to the additional resources to this chapter. 5.1 of questions and statements. Your teacher tells you that they are meeting two of their childhood friends this evening. One is 5 feet tall and the other is 6 feet tall. What is your guess as to each friend's gender based on this information? You might have guessed that the 5 foot tall person is a woman and the 6 foot tall person is a man. There is a chance that you are wrong, but experience tells us that 5 foot tall men and 6 foot tall women are rare. We have noticed that more often men are taller than women. The above is a simple example of statistical thinking. We regularly come across statements like Jamima's batting has been very consistent over the past year. We can expect a century from her in tomorrow's match. I take about 15 minutes to cycle from school to home. I think my pen might last for 2 more weeks. It is time to get a new one soon. The population of this village has reduced to about 100 in the last decade. Since I started to eat fruits and vegetables more frequently, I am able to run 2 kilometers more each day. David spends about 7 hours daily in the school. Page number 98. We call these statistical statements. Simply put, a statistical statement is a claim or summary about some phenomenon expressed in terms of numerical values, proportions, probabilities, or predictions. A statistical question is a question that can be answered by collecting data. For example, how tall are grade 7 students in our school? Is a statistical question. We expect that not all grade 7 students have the same height, but we can collect data, analyze it, and make conclusions about the heights that do occur. The question typically are onions costlier in Yahanpur or Wahanpur is also a statistical question. Prices can vary over time. Therefore, answering this question requires us to look at data, analyze it, and come to conclusions, making suitable statistical statements. Which of the following are statistical questions? A. What is the price of a tennis ball in India? B. How old are the dogs that live on this street? C. What fraction of the students in your class like walking up a hill? D. Do you like reading? E. Approximately how many bricks are in this wall? F. Who was the best bowler in the match yesterday? G. What was the rainfall pattern in Barmer last year? The term statistics refers to the study of collecting, organizing, analyzing, interpreting, and presenting data. In this chapter, we shall encounter some statistical questions and learn how analyzing data and graphs can help answer them. 5.2 Representative Values. The runs scored by Shubman and Yashasvi in a cricket series are given in the table. Who do you think performed better? The table reflects the scores in 4 matches played by Shubman and Yashasvi. Shubman scores 0 in first match and Yashasvi scores 67. In match 2, Shubman scores 17 and Yashasvi scores 55. In third match, Shubman scores 21 and Yashasvi scores 18. In match 4, Shubman scores 90 and Yashasvi scores 35. Shreyas says both their performances are similar since Yashasvi scored more in the first and second matches, whereas Shubman scored more in the third and fourth. There is a picture of Shreyas on this page. Page number 99. Vaishnavi says, I think Shubman performed better because he scored the highest number of runs in a match, 90. Shreyas says, no, Yashasvi batted better since the total number of runs he made is 175, while Shubman made only 128. Vaishnavi says, oh, also Yashasvi's batting is more consistent. The difference between his maximum score and minimum score is lower. The table given here represents the runs scored by these two players in another series. Who do you think performed better in this series? Here we have scores of Shubman and Yashasvi in 5 different matches played. In first match, Shubman scores 23 and Yashasvi scores 26. In match 2, Shubman scores 7 and Yashasvi scores 53. In match 3, Shubman scores 10 and Yashasvi scores 2. In match 4, Shubman scores 52 and Yashasvi scores nil. In match 5, Shubman scores 18 and Yashasvi scores 15. Vaishnavi says, here Shubman performed better since this total is 110 runs, while Yashasvi's total is 96 runs. We can find a picture of Vaishnavi on the right side of the page. What do you think of Vaishnavi's statement? Shreyas says, but Yashasvi made 96 runs in 4 matches and Shubman made 110 runs in 5 matches. So, how do we say who performed better? It is often not simple to compare two groups of numbers and clearly say that one is better than the other. Can a single number act as a representative of a group of numbers? For example, can we represent Shubman's or Yashasvi's batting in this series with one number? Discuss. We saw one way already, the total of the values in the group. But if the group sizes are different, then the total may not be an appropriate measure to compare. In some matches, a player could have scored more and in some other matches, less. A representative number for the group can be found by balancing out these highs and lows. For example, we can add up the runs scored in all the matches and divide the total by the number of matches played. We call this value the average or arithmetic mean of the given data. Here, the average number of runs scored by a player in a match is equal to total runs scored by the player in all the matches divided by number of matches played. Average number of runs scored by Shubman in a match is equal to 110 divided by 5 is equal to 21 runs. Average number of runs scored by Yashasvi in a match is equal to 96 divided by 4 is equal to 24 runs. In this series, Yashasvi's average number of runs is higher than Shubman's. Page number 100. The average or arithmetic mean AM or simply mean is calculated as follows. Mean is equal to sum of all the values in the data divided by number of values in the data. Average as fair share. The average can also be understood as fair share or equal share. Shreyas and 4 of his friends have collected the following numbers of Goas: 3, 8, 10, 5 and 4. Parag and 5 of his friends have collected the following numbers of Goas: 5, 4, 6, 3, 4 and 8. Each group will share their Goas equally amongst themselves. In which group will each member get a bigger share of Goas? To find this out, we first find out how many Goas each group has collected. Then we divide this total by the number of people in the group to get each member's share. Shreya's group has collected 3 plus 8 plus 10 plus 5 plus 4, that is equal to 30 Goas. Each member of Shreya's group gets 30 divided by 5, that is equal to 6 Goas. Parag's group has collected 5 plus 4 plus 6 plus 3 plus 4 plus 8 is equal to 30 Goas, and each member of the Parag's group gets 30 divided by 6 is equal to 5 Goas. So, the members of Shreya's group get one more Goa each than the members of Parag's group. There is a pictorial representation of these distribution of Goas. Here we have 3 plus 8 plus 10 plus 5 plus 4 is equal to 30, which can be expressed as 6 times 5 is equal to 30. And in other case, 5 plus 4 plus 6 plus 3 plus 4 plus 8 is equal to 30, which can be distributed as 6 into 5 is equal to 30. Vaishnavi tracks the number of hibiscus flowers blooming in her garden each day. The data for the last few days is 2, 7, 9, 4, 3. What is the average number of hibiscus flowers blooming per day in Vaishnavi's garden? The average is equal to the total number of hibiscus flowers bloomed divided by number of days. That is equal to 2 plus 7 plus 9 plus 4 plus 3 divided by 5. That is equal to 5. Page number 101. On an average, 5 hibiscus flowers bloom daily. In this case, the average tells us the number of flowers blooming each day. If an equal number of flowers bloomed daily, one of the terms used for the arithmetic mean in ancient Indian mathematics is samamiti, mean measure. Sama means equal. Some terms used for the arithmetic mean in Indian text include samaraju, mean measure of a line segment, by Brahmagupta 628 CE. Samikarna, leveling, equalizing, by Mahavircharya 850 CE. Samya, equality, impartiality, equability towards, by Shripati 1039 CE. And Samamiti, mean measure, by Bhaskaracharya in 1150 CE and Ganesha in 1545 CE. The terminology shows that ancient Indian scholars perceived the arithmetic mean as the common or equalizing value, that is, a representative measure of a collection of values. Figure it out. Question number 1. Shreyas is playing with a bat and a ball, but not cricket. He counts the number of times he can bounce the ball on the bat before it falls to the ground. The data for 8 attempts is 6, 2, 9, 5, 4, 6, 3, 5. Calculate the average number of bounces of the ball that Shreyas is able to make with his bat. Here we can find picture of Shreyas with a bat and ball making bounces. Question number 2. Try the activity above on your own. Collect data for 7 or more attempts and find the average. Question number 3. Identify a flowering plant in your neighborhood. Track the number of flowers that bloom every day over a week during its flowering season. What is the average number of flowers that bloomed per day? Question number 4. Two friends are training to run a 100-meter race. Their running times over the past week are given in seconds. Nikhil 17, 18, 17, 16, 19, 17, 18. Sunil 20, 18, 18, 17, 16, 16, 17. Who on average ran quicker? Question number 5. The enrollment in a school during 6 consecutive years was as follows: 1555, 1670, 1750, 2013, 2040, 2126. Find the mean enrollment in the school during this period. Know your onions. The table displays the monthly price of onions in rupees per kilogram kg at 2 towns. Where are onions costlier according to you? Page number 102. We have 2 different columns, one for the month and other for the price of onions at Yahanpur. In the month of January, the price is 25 rupees. In February, it is 24 rupees. For March, it is 26 rupees. For April, rupees 28. For May, it is 30 rupees. For June, it is 35 rupees. For July, it is 39 rupees. August, 43 rupees. September, 49 rupees. October, 56 rupees. November, 59 rupees. And in December, 44 rupees. There's another column for month and Wahanpur. Here, the cost of onions at Wahanpur for various months are given. In January, it is 19 rupees. In February, it is rupees 17. In the month of March, it is 23 rupees. April, 30 rupees. In the month of May, 38 rupees. June, 35 rupees. July, 42 rupees. August, 39 rupees. September, 53 rupees. October, 60 rupees. November, 52 rupees. And in December, 42 rupees. Khushbu says, I think Mahapur is costlier because it has the highest price of 60 rupees. Nafisa says, I added the prices of all months in each location. Yahanpur's total is 458, whereas Mahapur's total is 450. Vishal, Mahapur is costlier since it has 3 numbers in the 50s. Sampath says, I compared the prices in each month in both locations. Prices in Yahanpur are higher for 6 months. Prices in Wahanpur are higher for 5 months. And the prices are the same for 1 month. So, I feel Yahanpur is costlier. Jitin says, I noticed that the difference between the highest and the lowest prices in Yahanpur is 59 minus 24, that is 35 rupees. And in Wahanpur, it is 60 minus 17, that is equal to 43 rupees. Data can be described and compared by referring to its minimum value, maximum value, the average value, the sum total of all its values, and the difference between the maximum and minimum values. Can you think of any other ways to compare the data? To study data, we can visualize it in multiple ways. One way is given here. It is called a dot plot. Dot plots represent data points as dots on a line, helping us visualize variability and patterns in data. In the following figure, each dot represents the monthly price of onions. Page number 103. Here we have two different dot plots for Yahapur and Wahapur, in which we have the values between 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Between 20 to 30, we have 5 dots. Between 30 to 40, there are 2 dots. And between 40 to 50, there are 3 dots. And between 50 to 60, there are 2 dots. In Wahapur, we have again the same type of representation of the dot plot. Between 10 to 20, we have 2 dots. Between 20 to 30, there are 2 dots. And between 30 to 40, there are 3 dots. And in between 40 to 50, there are 2 dots. Between 50 to 60, there are 3 dots. It is also represented here that two of the values are 39, one belonging to each of Yahapur and Wahapur. In Wahapur, one of the values is 19. Here, it refers to one of the monthly prices of Wahapur. In Wahapur, two of the values are 42, both belonging to Wahapur. The prices in Yahapur are in green and those in Wahapur are in purple. The horizontal line gives the prices from 10 to 60 instead of starting from 0, as there are no values from 0 to 10 or above 60. The dots on the vertical line give the number of occurrences of a data value. Notice the equal spacing between the units along the horizontal as well as the vertical lines. Does this visualization capture all the data presented in the tables earlier? Observing them, can we tell the prices of onions in Yahapur in the month of January? This method of presentation orders or sorts the data, but it loses the original month-wise sequence of the values. However, it allows us to group the data however we wish, just as Vishal did. For instance, there are two data values between 11 to 20 for Wahapur, while Yahapur has none. This representation makes it easier to observe the variation in the data, where and how the data is clustered or spread out. We easily find that the prices in Wahapur are more spread out than those in Yahapur. It is also easy to spot the highest and lowest values. We can also use the average as one of the ways to compare the prices at these two places. Page number 104. Find the average price of onions at Yahapur and Wahapur. A statement such as the price of onions is 35 rupees per kilo may not trigger any further questions. But looking at variations in data, like the prices of onions over a year in Yahapur and Wahapur, can spark one's curiosity. For example, one might be curious to know more about the two locations. You might wonder, do the seasons affect the price of onions? Where are these two locations? Are they close to each other or far apart? What are the factors that determine the price of onions? How much do onions prices vary across shops in the same area? What other commodities might have similar patterns? How do the price fluctuations impact farmers, consumers, and the industry? These questions are from the kids who are visible in this picture. What else do you wonder about? You can discuss questions that you are curious about with your peers, teachers, or family members to find answers. An owl musket appears here and says, observing and trying to make sense of data can reveal interesting things. It can also trigger our curiosity in different directions. Averages around us. The arithmetic mean is frequently used in statistics, mathematics, experimental sciences, economics, sociology, sports, biology, and diverse disciplines as a representative of data. Page number 105. It is popular partly because the definition of the arithmetic mean is simple and easy to understand. Some statements involving averages in different scenarios are given here. First, the average rainfall per day in Jharkhand in the month of July is 37.2 millimeters. We find a picture of cloud and the rain occurring here. In the next picture, my scooty's average mileage this year is about 45 kilometers per liter. Here we can find a scooter and 45 kilometers per liter is reflected in the picture. In third picture, wheat yield averages 4.7 tons per hectare in Punjab versus 2.9 tons per hectare in Bihar. We can find a gunny bag with paddy here, with wheat given here. In the next picture, we find a boy with a smartphone. Smartphone users check their phone 58 times a day on average. In the next picture, an average Indian citizen generates 0.45 kg of waste per day. We can find man standing with a broom and a dustbin around. In the next picture, we have 3126 is the average number of Indian long films released annually between 2017 and 2024. Outliers and medians. Does the average always give a reasonable summary of the values in a collection? If not, what is an alternative? Let us find out. Height of a family. The heights of a family members of Yanga and Puvizi are as follows. Yanga's family 169 centimeters, 173 centimeters, 155 centimeters, 165 centimeters, 160 centimeters, and 164 centimeters. Puviji's family 170 centimeters, 173 centimeters, 165 centimeters, 118 centimeters, 175 centimeters. Find the average height of each family. Can we say that Yanga's family is taller than Puviji's family? Page number 106. The average height of Puviji's family 160.2 centimeters is less than that of Yanga's family 164.3 centimeters. Although most members in Puviji's family are taller, their family's average height is less because one child is much younger and not as tall as rest of the family. Their average height 160.2 centimeters is less than the height of 4 out of 5 members. Here, the average doesn't seem to represent the data very well. We have the pictorial representation for the same, in which mean is equal to 164.3, for Poviji's family and mean is 160.2 for Yanga's family. We have a dot plot for both the families' height. For Poviji's family, the average height is 160.2 and for Yanga's family it is 164.3 centimeters. Can you think of any other number that can represent the data better? One way is to sort the data and pick the number in the middle. This number is called the median. To find the median height of Poviji's family, we first sort the heights 118, 165, 170, 173, 175. The middle number in this sorted data is 170. Therefore, the median height is 170 centimeters. Let us find the median height of Yangba's family. Sorting the heights, we get 155, 160, 164, 165, 169 and 173. Since the median is the number in the middle, it will have an equal number of values less than it and greater than it. This data does not have a single middle number because it has an even number of values, that is 6. In such cases, we take the average of the two middle numbers in the sorted data. Therefore, the median height of Yangba's family is 164 plus 165 divided by 2, that is equal to 164.5 centimeters. Here we have dot plot for both the families' height. Mean is 164.3 and median is 164.5 for Yangba's family, and it is mean is 160.2 and median is 170 for Poviji's family. In this case, does the median represent the heights of the families better than the average? Page number 107. In Poviji's family, the height of the youngest child is quite different from the heights of the rest of the family. We call such a value an outlier. Outliers are values which significantly deviate from the rest of the values in the data. Notice how the mean and the median are close to each other in Yangba's data in the absence of any outlier. In Poviji's data, because of the outlier, the mean is much lower than the median. Here we have a picture of the members of Poviji's family in which the child is having a lesser height compared to the other members of the family. Find the mean and median in Poviji's data without the outlier value 118. What change do you notice? Are you a bookworm? After the summer vacation, a class teacher asked his class how many short stories they had read. Each student answered the number of stories read on a piece of paper as given here. Find the mean and median number of short stories read. Before calculating them, can you guess whether the mean will be less than or greater than the median? Here we find some piece of papers on which the numbers are written as 3, 6, 0, 2, 8, 5, 7, 15, 12, 10, 40, 5, 0, 1 and 8. Mark the data, the mean and the median on the dot plot given here. We have a scale provided and you are supposed to mark the data in this table. The median value 6 means that half of the class members have read 6 or more stories. Page number 108. Which of the values would you consider an outlier? Find the mean and median in the absence of the outlier. What change do you notice? The average may not always be an appropriate representative of data that has outliers. A very high or a very low outlier can significantly impact the sum, thus affecting the average. For example, the 118 centimeter height in Poviji's family is an outlier at the lower end of the data, and the count of 40 short stories read is an outlier at the higher end of the data. In these cases, we found that the median was not affected much by the outliers. Are we on the same page? Do you read newspapers? Have you noticed how many pages a newspaper has on different days of the week? Is it the same or different? The list here gives the number of pages for a particular newspapers from Monday to Sunday: 16, 18, 20, 22, 26, 16, 10. Mark the data, the mean and the median on the dot plot given here. In the three examples we considered, the heights, short stories, the newspaper pages, observe the variability in data when A. The mean and the median are close to each other. B. The mean and the median are comparatively far apart with mean less than median. C. The mean and median are comparatively far apart with mean greater than median. When the data is more balanced or uniformly spread out, the mean and the median appear to be close to each other. When the outlier is on the lower end, the mean appears to shift in that direction. That is, mean is less than median. When the outlier is on the higher end, the mean appears to shift in that direction. That is, mean is greater than median. Page number 109. Discuss the effect on the mean and median when outliers are present on both sides. You may take some example data to examine and explain this. Mean and median are called measures of central tendency, that is, the tendency of the values to pile up around a particular value. In other words, they represent the center of the data, of ends and the essence. As we have just observed, the mean and the median can give different perspectives on the data. As part of analyzing data, it can also be valuable to look at the variability in the given data, that is, its extremes, minimum and maximum values. How tall is your class? Suppose you are asked the question, how tall is your class? What would you say? The table here gives the height of students in a grade 5 class in centimeters, boys and girls. The heights mentioned are 147, 135, 130, 154, 128, 135, 134, 158, 155, 146, 146, 142, 140, 141, 144, 145, 150. The height of girls: 143, 136, 150, 144, 154, 140, 145, 148, 156, 150, 150. We can visualize the data using a dot plot, identify the ends and the patterns, and look at the variability. We can also find the measures of central tendency. The dot plot for the whole class, followed by the dot plot for boys and girls, respectively, are given here. The mean and the median are also represented for each collection. For the whole class, the mean is 144.4 and median is 145. This can be observed from the given dot plot. For boys, the mean is 142.94 and median is 144. This has been represented in the dot plot here. And for girls, the mean is 146.9 and median is 148. There is a dot plot for girls here. Page number 110. What can we infer from the dot plots and the central tendency measures? The following points can help answer the questions on how tall the class is. The boys' heights are more spread out and are between 128 and 158. The girls' heights lie between 136 and 156. Both the tallest and the shortest in the class are boys. Yet, the boys' average height is less than the whole class height and also less than the girls' average height. We can say girls are taller than boys in this class. Of course, this doesn't mean every girl is taller than every boy. For boys' heights, mean is less than median, 142.94 is less than 144, indicating a small influence of values on the lower side. For girls' heights too, mean is less than median. 146.9 is less than 148, indicating a small influence of values on the lower side. How many students are taller than the class average height? How many boys are taller than the class average height? How long is a minute? Two groups of children were asked to estimate the length of 1 minute. They start by closing their eyes and then open when they think 1 minute has passed. Of course, they are not supposed to count while their eyes are closed. The dot plot here reflects after how many seconds the children opened their eyes. Discuss how well both the groups fared at this activity. Describe and compare the variability in data and their central tendency. We have two visual representations of the dot plots for Group A and Group B. In Group A, the mean is 58.21 and median is equal to 60. And for Group B, the mean is 59.28 and median is 59.5. Page number 111. Zero median runs scored. In a cricket match, can a team's median runs scored by a player be 0, but the team's total score be 407 upon 10? In yesterday's match, the median runs scored by England players was 0, and yet the team scored 407 for the loss of 10 wickets, says a small girl visible in the picture. And there's a boy who is reading this news in the paper on sports. Accounting for the extras, the average run scored by a player in this innings is 407 minus 19 within brackets divided by 11, that is equal to 35.27. 0 versus no value. Suppose a player scores 57, 13, 0, 84, dash, 51, 27 in a series. Notice that the player played match 3 and scored 0 runs, whereas the player did not play match 5. So we consider the total number of matches to be 6 and not 7. We calculate their average runs scored per match as 57 plus 13 plus 0 plus 84 plus 51 plus 27 divided by 6. Sita has a mango tree in her backyard. The number of mangoes the tree gave every month over the last year from January to December is 008, 24, 41, 16, 5, 000, respectively. If we want to find the mean or median number of mangoes per month, it would be appropriate to consider only the summer months when mangoes are expected to grow. Page number 112. A mean foot. In the early 1500s in Europe, the basic unit of land measurement was the rod, defined as 16 feet long. At the time, a foot meant the length of a human foot. But foot sizes vary. So, whose foot could they measure? To solve this, 16 adult males were asked to stand in a line, toe to heel, and the length of that line was considered the 16-foot rod. After the rod was determined, it was split into 16 equal sections, each representing the measure of a single foot. In essence, this was the arithmetic mean of the 16 individual feet, even though the term mean was not mentioned anywhere. Here we find a picture of Jacob Koebel's depiction of the determination of 1 foot. Figure it out. Question number 1. Find the median of onion prices in Yahanpur and Wahanpur. Question number 2. Sanskriti asked her class how many domestic animals and pets each had at home. Some of the students were absent. The data values are 0, 10, 4800, 211, 534, 00 10, 25, 2 24. Find the mean and median. How would you describe this data? Question number 3. Rintu takes care of a date palm tree farm in Habra. The heights of the trees in feet in his farm are given as 50, 45, 43, 52, 61, 63, 46, 55, 60, 55, 59, 56, 56, 49, 54, 65, 66, 51, 44, 58, 60, 54, 52, 57, 61, 62, 60, 60, 67. Fill the dot plot and mark the mean and median. How would you describe the heights of these palm trees? Can you think of quicker ways to find the mean? How many trees are shorter than the average height? You are supposed to fill up the dot plot given here with the values of mean and median. Question number 4. The daily water usage from a tap was measured. The usage in liters for the first few days are 5.6, 8, 3.09, 12.9, 6.5, 12.1, 11.3, 20.5 and 7.4. A. Can the mean or median daily usage lie between 25 and 30? Justify your claim using the meaning of mean and median. B. Can the mean or median be lesser than the minimum value or greater than the maximum value in a data? Question number 5. The weights of a few newborn babies are given in kgs. Fill the dot plot provided here. Analyze and compare this data. Page number 113. We have data for boys and girls as 3.5, 4, 4.1, 3.1, 2.6, 3.4, 3.2, 3.7, 3.4, 2.5, 3.8 and 3.4 respectively. This data is to be filled in the dot plot provided here. Question number 6. The dot plots of heights of another section of grade 5 students of the same school are given here. Can you share your observations? What can we infer from the dot plots and the central tendency measures? For the whole class, we have a dot plot with mean value is equal to 141.21, median is equal to 142.5, and we have dot plot for boys reflecting mean is equal to 142.05 and median is equal to 143. For girls, we have a dot plot with value of mean as 140.14 and median is equal to 140. Compare the heights of the two sections. Share your observations. Question number 7. The weights of some sumo wrestlers and ballet dancers are: sumo wrestlers 295.2 kgs, 250.7 kgs, 234.1 kgs, 221.0 kgs, 200.9 kgs, ballet dancers 40.3 kgs, 37.6 kgs, 38.8 kgs, 45.5 kgs, 44.1 kg, 48.2 kgs. Approximately how many times heavier is a sumo wrestler compared to a ballet dancer? We have a picture of a balance. On one, we have a sumo wrestler, and on the other end, we have 4 ballet dancers. Page number 114. Visualizing data. We can often understand data more clearly if it is presented as a picture. This is called data visualization. Last year, we saw how to visualize data using graphs. Let us explore visualization further. Clubbing the columns. Earlier, we looked at the monthly onion prices in Yahanpur and Wahanpur. We have the data here, which has been used to represent the column graphs. 2 column graphs for this data are given. Monthly onion price in Yahanpur is reflected in blue color, and monthly onion prices in Wahanpur is reflected in red color. On x-axis we have the months, and on y-axis we have the prices mentioned in the vertical columns. Page 115. The two graphs can also be combined into a single graph. We just draw the bars side by side. Verify if the data in the table matches the graph given here. Monthly onion prices in Yahanpur and Wahanpur. Blue color reflects Yahanpur and red color reflects Wahanpur. We have double column graph here, in which on the horizontal line we have the months and in vertical line we have prices in rupees. We use different colors to clearly separate the data from the two places. This is called clustered column graph. Since it has two columns in each cluster, we also call it as double column graph. What is the scale used in this graph? The relative heights of the bars tell us where onions are costlier in each month. We can also visually estimate the difference by referring to the markings along the vertical line. The dot and the slanted lines within the bars help people who find difficulty in distinguishing colors. It is also useful when things are printed in grayscale, that is black and white. Is it now easier to compare month-wise prices in both places? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, take off. You might have heard about scientific probes like Chandrayaan-3 launched in 2023 by ISRO, or the Voyager 1 launched in 1977 by NASA. Observational satellites like Aryabhatta launched in 1975 by ISRO, or Sputnik 1 launched in 1957 by the Soviet space program, or about human space flights to the International Space Station. All space missions are launched using rockets. Page number 116. Observe the graph given here representing the number of worldwide rocket launches by different organizations. Share your observations. You may take the teacher's help to identify the countries these organizations belong to. Number of worldwide rocket launches by companies and space agencies. We have different agencies as SpaceX, CASC, Roscosmos, Arianespace, Rocket Lab, United Launch Alliance, ISRO, Galactic Energy, X-Space, and others. The source here is the link has been provided for this https www.statista.com/chart/29410 number of worldwide rocket launches by companies and space agencies. Often, there is a lot of information in graphs and it may be difficult to understand. We can follow a two-step process to simplify making sense of the data in graphs. Step 1. Identify what is given. Notice how the graph is organized, what scale is used, and what patterns the data represents. There's a picture of a boy who says, "I wish they had given guidelines for 5, 10, and 15 along the horizontal line. It would help in estimating the smaller numbers." Page number 117. For each organization, the numbers of rocket launches for the years 2021, 2022, and 2023 are given as three adjacent bars. The scale used is 1 unit length is equal to 20 rockets. Notice the numbers at the bottom. The others category indicates multiple organizations worldwide that are clubbed together to keep the graph short. Note that in the double bar graph of onion prices, the months are represented in order, that is, January to December, to observe the change over time, whereas in this case, a change in the order of organizations does not affect the meaning. Here in the picture, we find that on the vertical line, we have SpaceX, CASC, Cosmos, Arianespace, Rocket Lab, United Launch Alliance, ISRO, Galactic Energy, and X-Space. On the horizontal line, we have 0, 20, 40, 60, 80, 200. Increasing year on year, bar length of 2022 is almost double that of 2021. Decreasing year on year, bar length of 2023 is almost half of 2022. For United Launch Alliance, increase and then decrease is observed. For others, the 2023 count of objects in this category is around 25. Step 2. Infer from what is given. Analyze and interpret each of your observations. We can say that the USA, China, and Russia are the leading rocket launching countries in the given time period. SpaceX launched about twice the number of rockets in 2022 compared to 2021, and it launched about 35 more rockets in 2023 compared to 2022. The number of rockets launched by Arianespace decreased every year. United Launch Alliance launched more rockets in 2022 than in 2021. They launched fewer rockets in 2023 than in both the years 2022 and 2021. Other organizations launched about 25 rockets in 2023. Page number 118. Identify which of the following statements can be justified using this data. A. All organizations launched more rockets than the previous years. B. Only an organization from the USA launched more than 50 rockets in a single year. C. the total number of rockets launched by France in all 3 years is less than 40. D. The average number of rockets launched by CASC in these 3 years is around 40. E. ISRO launched more rockets than Galactic Energy in these 3 years. F. Russia launched more than 60 rockets in these 3 years. List the organizations that have consistently launched more rockets every year. Estimate the total number of rockets launched worldwide in 2023. A. Less than 200. B. 200 to 400. C. 400 to 600. D. More than 600. We may have many questions after observing the graph. We might wonder why USA launches so many more rockets than other countries. Or we might be eager to look at the data from previous and later years. What are you curious to know after observing these graphs? Summer and winter at the same time? The tables below represent data related to weather in two cities in different countries. The numbers given are in hours. Can you guess what the data might be related to? City 1, January 210, February 257, March 372, April 441, May 536, June 564, July 555, August 465, September 394, October 310, November 222, December 186. City 2, January 459, February 384, March 381, April 327, May 304, June 276, July 295, August 318, September 369, October 409, November 435, December 468. Page number 119. The data reflects the monthly hours of daylight, that is, the sun is at least partly above the horizon in these two cities over the year. Based on this data, a clustered bar graph representing the average daylight hours per day in each month is given here. This average is obtained by dividing the monthly daylight hours by the number of days in the month. Here we have a graphical representation. On horizontal line we have months and on vertical line we have number of hours per day. And the graph represents average daily sunshine hours in two cities. Orange color is for city 1 and blue reflects city 2. Let us follow the two-step process to identify and interpret the information presented. Step 1. Identify what is given. Notice how the graph is organized, what scale is used, and what patterns the data represents. The horizontal line represents the months of the year. The vertical line represents the average daylight hours per day. Using the scale 1 unit is equal to 5 hours. The month of June has the maximum value for city 1 and the minimum value for city 2. Step 2. Infer from what is given. Analyze and interpret each of your observations. Share appropriate summary and conclusion statements. The average number of daylight hours per day in city 1 increases from January, reaching a maximum of about 17 to 18 hours in June. It then decreases, reaching a minimum of about 6 hours in December. Page number 120. The average number of daylight hours per day in city 2 decreases from January, reaching a minimum of about 9 hours in June. It then increases, reaching a maximum of about 15 hours in December. The maximum and minimum value in City 1 are more extreme than those of City 2. That is, the maximum number of daylight hours per day of City 1 is more than that of City 2, and the minimum number of daylight hours per day of City 1 is less than that of City 2. In June, City 1 experiences daylight for about 3 upon 4th of the full day in 24 hours, whereas during December to January, it only experiences daylight for about 1/4 of the full day. Does this give some idea of where these two cities are located? City 1 and City 2 are located away from the equator in the northern and southern hemispheres, respectively. City 1 is Helsinki, Finland, and City 2 is Wellington, New Zealand. These are also represented on the map. In June, the northern hemisphere is tilted towards the sun, resulting in longer daylight hours. It is summertime here. Meanwhile, the southern hemisphere is tilted away from the sun, leading to shorter days. It is winter time here. The inverted seasonal daylight pattern is due to the city's location in opposite hemispheres. The large variation in the data is because they are away from the equator. We also have a map of the world representing these two, City 1 and City 2. Helsinki, Finland in the northern hemisphere, and Wellington, New Zealand in the southern hemisphere. Page number 121. Is there anything more that you wish to explore? The girl in the picture says, I got to know that during summer, near the poles, one can see the sun even at midnight. The boy in the picture says, very interesting. If we are there at that time, we can go sightseeing even at midnight. There's another picture on this page of the midnight sun at Andøya, that is Norway. All it takes is a minute. Have you ever missed watching a cricket match? You can catch it in a minute by looking at the graph. You might have noticed the graphs like the following one. Page number 122. Here we have a graph representing overs on the horizontal axis and runs per over on the vertical axis in red and blue columns. The horizontal line lists the overs starting from 1 and the vertical line indicates the runs scored in each over. The graph represents the number of runs scored per over as a double bar graph, each bar corresponding to a team. Let us call them the blue team, denoted by blue, and the red team, denoted by red. The scale used for the runs per over is 1 unit is equal to 5 runs. The circles represented on top of the bars indicate that a wicket fell in that over. Answer the following questions based on the graph. Question number 1. Can we tell who batted first? Who won the match? Question number 2. How many runs did the blue team score in over 12? Question number 3. In which over did the red team score the least number of runs? Question number 4. Is it easy to tell the target set by the team batting first? Figure it out. Question number 1. The following infographic represents the speed of a few animals, in air, on land, and in water. Can we call this graph a bar graph? A. What is the scale used in this graph? B. What did you find interesting in this infographic? What do you want to explore further? C. Identify a pair of creatures where one speed is about twice that of the other? D. Can we say that a sailfish is about 4 times faster than a humpback whale? Can we say that a sailfish is the fastest aquatic animal in the world? Page number 123. Here we are provided with the maximum speeds of animals in air, on land, and in water. To begin with, we have peregrine falcon. The speed represented here in the graph is 322 kilometers per hour. Then we have spine-tailored swift. Speed is 170 kilometers per hour. Free-tailored bird having speed 96 kilometers per hour. Then we have green dragonfly having speed 64 kilometers per hour. Flying fish having speed 56 kilometers per hour. The speeds mentioned till now is of the birds in air, and now we will have the speed of animals on land. Cheetah 103 kilometers per hour, paragon antelope 88 kilometers per hour, ostrich 64 kilometers per hour, human 37 kilometers per hour, and Australian tiger beetle 8 kilometers per hour. Now we have speed of aquatic animals mentioned here in the graph. Sailfish 109 kilometers per hour, dolphin 40 kilometers per hour, California sea lion 40 kilometers per hour, Gentoo penguin it is 35 kilometers per hour, humpback whale 26 kilometers per hour. The picture represents the peregrine falcon is the world's fastest animal. It hunts by diving at high speed and striking a pigeon or other bird in midair. The Australian tiger beetle is also in this picture, which moves at a blistering pace about 120 body lengths per second. Its eye can't process images fast enough to keep up. So, at top speed, this beetle is running blind. Page number 124, question number 2. Priyashi asked her students, if you were to get a superpower to become aquatic waterborne, aerial, airborne, or spaceborne, which one would you choose? The responses are given here. Some choose none. Draw a double bar graph comparing how both grades choose each option. Choose an appropriate scale. Grade 5 and grade 9. We have W, A, W, NSA, NW, AA, WWS, AAN, WAAN. Grade 9, N, W, S, AS, W, SS, AA, W, SSA, SAN, W, SSA, W, AWA. Question number 3. The temperature variation over 2 days in different months in Jodhpur, Rajasthan is given here. Draw a double bar graph. Use the scale 1 unit is equal to 4 degrees Celsius. Can you guess which 2 months these days might belong to? We have time mentioned as 12 am, day 1 20 degrees Celsius, day 2 37 degrees Celsius. At 3 am on day 1 temperature is 18 degrees Celsius, on day 2 it is 34 degrees Celsius. At 6 am day 1 temperature is 16 degrees Celsius, on day 2 it is 30 degrees Celsius. At 9 am day 1 temperature is 20 degrees Celsius, day 2 it is 33 degrees Celsius. At 12 pm day 1 temperature is 26 degrees Celsius, day 2 it is 37 degrees Celsius. At 3 pm day 1 temperature is 34 degrees Celsius, day 2 43 degrees Celsius. At 6 p.m., day 1 temperature is 30 degrees Celsius, day 2 it is 42 degrees Celsius. At 9 p.m., day 1 temperature is 24 degrees Celsius and day 2 it is 39 degrees Celsius. Question number 4. The following clustered bar graph represents the number of electric vehicles registered in some states every year from 2022 to 2024. Number of electric vehicles registered per year. We have representations for 2022 in blue, 2023 in red, and 2024 in yellow. 3 different colors are used for states Uttarakhand, West Bengal, Andhra Pradesh, Odisha, Assam. For Gujarat and Delhi, there are no registrations, and the values depicted on vertical line are 25,000, 55,000, 25,000, 50,000, 75,000 and 1 lakh. Page number 125. A. The data rounded off to thousands for the states of Gujarat and Delhi are given in the table. Mark the corresponding bars on the bar graph. It is enough if you place the top of the bars between the two appropriate vertical guidelines. In 2022, Gujarat has 69,000 and Delhi 62,000. In 2023, Gujarat reflects 89,000 and Delhi 74,000. In 2024, Gujarat reflects 78,000 and Delhi reflects 81,000. B. Notice how the graph is organized, what scale is used, and what patterns the data reflects. C. How would you describe the change for various states between 2022 and 2024? D. Approximately how many more registrations did Assam get in 2023 compared to 2022? E. How many times more did the registrations in West Bengal increase from 2022 to 2024? F. Is this statement correct? There were very few new registrations in Uttarakhand in 2023 and 2024 as the increase in the bar lengths is minimal. 5.4 Data Detective. We put well-formed sentences one after the other to make a beautiful story. In the same way, well-organized and well-presented data can tell interesting stories and can also expose new mysteries or help solve mysteries. Telling tall tales. Earlier, we observed data of 2 grade 5 classrooms with heights of boys and girls in each class. There, the average height of girls was more than boys in one class and vice versa in the other class. Following are the dot plots of heights of boys in blue and girls in orange of grades 6, 7 and 8 in that order of 2 different schools. What do you notice? Share your observations. Page number 126. We have dot plots for school A and for school B. For school A, the mean here is 134.8 for boys, and for girls, the mean is 137.78. In the next picture, we have mean is equal to 141.8 and for boys and 141.83 for girls. Likewise, for the different class, mean is 149.35 and 147.81. Likewise, for school B, the mean is 149.84 and for boys, and mean for girls is 150.2. For class 7, the mean here is 156.14 for boys and 155.41 for girls. Likewise, for class 8, the mean is 156.14 for boys and 156.83 for girls. By observing this data, you might wonder, why is there a considerable difference in heights in the same grades across these two schools? Where are these schools located? How tall are students in grade 6 to 8 in my school? What is the average height of all grade 6 boys and girls? We find that men are taller than women in general. But what about the heights of boys and girls? Are boys taller than girls? Well, just by observing the data of one or two schools, we cannot generalize for all children in our country or around the world. Let us explore some data based on a survey of the heights of boys and girls of different ages in India over time. The following table reflects the average heights of boys and girls in centimeters across ages 5 to 19 in the years 1989, 1999, 2009 and 2019. In each year, the first column represents boys' height and the second column represents girls' height. Page number 127. We are provided with 5 columns. The first column reflects the age. The second, third, fourth and fifth reflects the height of boys and girls respectively for the year 1989, 1999, 2009 and 2019. For age 5, we have 101.3 and 100. For age 6 years, 107.5 and 106. For age 7, 113 and 111.4. For age 8, 118.1, 116.5. For age 9, 122.9, 121.7. For age 10, 127.5, 127.3. For 11, 132.2, 133.4. For 12 years age, 137.7, 139. For 13 years age, 144.2, 143.2. For 14 years, 150.6 and 146.2. For 15 years, 155.4 and 148.5. For 16 years, 158.9, 150.1. For 17 years age, 161.3, 151.2. For 18 years of age, 162.9 and 151.8. For 19 years of age, 163.5 and 151.9. Now, for these ages in year 1999, we have the values for age 5 as 102.4 and 101.7. For 6 years, 108.7 and 107.5. For 7 years, 114.2 and 112.6. For 8 years, 119.2 and 117.5. For 9 years, 123.9, 122.4. For 10 years, 128.3 and 127.8. For 11 years, 132.8, 133.6. For 12 years, 138 and 139.1. For 13 years, 144.3 and 143.1. For 14 years, 150.5 and 146.1. For 15 years, 155.2 and 148.4. For 16 years, 158.7 and 150.1. For 17 years, 161.4 and 151.3. For 18 years, 163.2 and 152.1. For 19 years, 164.2 and 152.4. For 2009, at the age of 5, the values given here are 105.1 and 104. For 6 years, 111 and 109.7. For 7 years, 116.2 and 114.8. For 8 years, 120.9 and 119.6. For 9 years, 125.2 and 124.5. For 10 years, 129.4 and 129.9. For 11 years, 133.7 and 135.7. For 12 years, 138.9 and 141.1. For 13 years, 145.2, 145.1. For 14 years, 151.5 and 148. For 15 years, 156.3 and 150.1. For 16 years, 159.9 and 151.6. For 17 years, 162.6 and 152.6. For 18 years, 164.3 and 153. For 19 years, 165.1 and 153. Now for 2019, at the age of 5, the values given are 101.1, 107.2. For 6 years, 113.1 and 112.9. For 7 years, 118.6 and 118. For 8 years, 123.5 and 122.7. For 9 years, 128.1 and 127.6. For 10 years, 132.6 and 132.8. For 11 years, 137 and 138.6. For 12 years, 142.2 and 143.8. For 13 years, 148.4 and 147.7. For 14 years, 154.4, 150.4. For 15 years, it is 159 and 152.4. For 16 years, 162.3 and 153.8. For 17 years, 164.6 and 154.7. 18 years, 166 and 155.2. For 19 years, 166.5 and 155.2. Spend sufficient time observing the data presented in this table. Share your findings with the class. These are some prompts for you to probe. Changes in the heights of boys or girls of a certain age from 1989 to 2019. The heights of boys versus girls at different ages in a particular year. Changes in height between successive ages in boys and girls in 2019. Which of the following statements can be justified using the data? First, the average heights of both boys and girls at every age increased from 1989 to 2019. Second, the average height of 13-year-old girls in 1989 is more than the average height of 14-year-old girls in 2009. Third, the average height of 15-year-old boys in 2019 is more than the average height of 16-year-old boys in 1989. Fourth, all girls aged 13 are taller than all girls aged 11. Fifth, throughout the age period 5 to 19, the average boy's height is more than the average girl's height. Sixth, boys keep growing even beyond age 19. Page number 128. In 2019, between which two successive ages from 5 to 19 did boys grow the most? Between which two successive ages from 5 to 19 did girls grow most? Suppose the average height of a newborn is 50 centimeters. Estimate the average height of young children of ages 1 to 4. Based on the trend observed in the table, write your estimates of the heights of boys and girls for ages 5 to 19 in the year 2029. An owl musket appears here and informs whenever you observe data or some graph, look closely to know the story it has to say and the mysteries it may hold. You may want to look at the data of weights, or you might be curious to find if such patterns are present in other countries as well. You might also wonder if humans were more shorter a few centuries ago. Also, are people in some countries taller than others? The following visualization represents the change in average heights of 19-year-old boys and girls of different countries from 1989 to 2019. How is the graph organized? What information is presented? What do you find interesting? Notice that the vertical line starts from 145 centimeters. This helps give a closer, zoomed in look at the heights. We have a graph here. On vertical line, we have heights mentioned in centimeters, and we have various countries mentioned on the horizontal line like Netherlands, Iceland, Ukraine, Norway, Australia, UK, New Zealand, Libya, Turkey, Israel, China, South Korea, Egypt, Italy, Taiwan, Sudan, Japan, Saudi Arabia, Kenya, Maldives, Pakistan, Bhutan, India, Indonesia, Liberia, Bangladesh, Yemen, and Timor-Leste. Page number 129. A mean decision. Here we have two pictures. In one, kids are standing there and one of them says, perhaps using the average height of the family to make the door was not the good idea. One boy is struggling to enter the door. In another picture, one boy and girl are talking to each other and the girl says, look at this picture of the current world's tallest and shortest humans together. Figure it out. Question number 1. The dot plots given here represent the distribution of the number of pockets on clothing for a group of boys and for a group of girls. We have a dot plots for number of pockets for boys and for girls in this picture. Based on the dot plots, which of the following statements are true? A. The data varies more for the boys than for girls. B. The median number of pockets for the boys is more than that of the girls. C. The mean number of pockets for the girls is more than that of the boys. D. The maximum number of pockets for boys is greater than the number of girls. Question number 2. The following table represents the points scored by each player in 4 games. We have a tabular column in which we have 5 different columns. The first column represents the players A, B and C. And second, third, fourth and fifth column represent scores for game 1, game 2, game 3 and game 4. Player A scores 14 in game 1, 16 in game 2, 10 in game 3 and 10 in game 4. B scores 0 in game 1, 8 in game 2, 6 in game 3 and 4 in game 4. Player C scores 8 in game 1, 11 in game 2, did not play the game 3 and 13 in game 4. Page number 130. Now answer the following questions. A. Find the average number of points scored per game by A. B. To find the mean number of points scored per game by C, would you divide the total points by 3 or by 4? Why? What about B? C. Who is the best performer? Question number 3. The marks out of 100 obtained by a group of students in a general knowledge quiz are 85, 76, 90, 85, 39, 48, 56, 95, 81 and 75. Another group's scores in the same quiz are 68, 59, 73, 86, 47, 79, 90, 93 and 86. Compare and describe both the groups' performance using mean and median. Question number 4. Consider this data collected from a survey of a colony. We have a tabular column in which we have 6 columns. The first one reflects favorite sport, second reflects cricket, third basketball, fourth swimming, fifth hockey and sixth athletics. Under favorite sport, the people watching are 1240 in cricket, 470 in basketball, 510 in swimming, 430 in hockey and 215 athletics. For participating under favorite sport, we have 620 for cricket, 320 in basketball, 320 in swimming, 250 in hockey and 105 in athletics. Choose an appropriate scale and draw a double bar graph. Write down your observations. Question number 5. Consider a group of 17 students with the following heights in centimeters: 106, 110, 123, 125, 117, 120, 112, 115, 110, 120, 115, 102, 115, 115, 109, 115 and 101. The sports teacher wants to divide the class into 2 groups so that each group has an equal number of students. One group has students with heights less than a particular height and the other group has students with heights greater than the particular height. Suggest a way to do this. Can you guess the age of these students based on the tabular data in the Telling Tall Tales section? Question number 6. Describe the mean and median of heights of your class. You can visualize the heights on a dot plot. Question number 7. There are 2 7th grade sections at a school. Each section has 15 boys and 15 girls. In one section, the mean height of students is 154.2 centimeters. From this information, what must be true about the mean height of students in the other section? A. The mean height of students in the other section is 154.2 centimeters. B. The mean height of students in the other section is less than 154.2 centimeters. Page number 131. C. The mean height of students in the other section is more than 154.2 centimeters. D. The mean height of students in the other section cannot be determined. Question number 8. Standing tall in the storm. There is a picture here which represents cities with most skyscrapers, buildings taller than 150 meters. Hong Kong has 553 buildings. taller than 150 meters. Shenzhen has 367. New York, you have to estimate. Dubai has 251 buildings. And Guangzhou has 188 buildings. Shanghai has 183. You are supposed to estimate for Tokyo. And Kuala Lumpur has 154. Chongqing has 144. Jakarta has 112. Bangkok has 110. Singapore has 95. Mumbai has 86. Seoul has 82. Toronto has 81. Melbourne has 69. Miami has 58. Istanbul has 48. Moscow has 46. And London, you are supposed to estimate. A. Write estimated values for the number of skyscrapers in New York, Tokyo, and London. B. Are the following statements valid? First, only 12 cities have more skyscrapers than Mumbai. Second, only 7 cities have fewer skyscrapers than Mumbai. Third, the tallest building in the world is in Hong Kong. Question number 9. Estimate and then measure the objects listed in the following table. Draw a double bar graph based on the data. How accurate were your estimates? Find the average difference between the estimated and measured values. Question number 9. Estimate and then measure the objects listed in the following table. Draw a double bar graph based on the data. How accurate were your estimates? Find the average difference between the estimated and measured values. Page number 132. Here we have a tabular column in which we have 4 columns, first reflecting the object, second, third and fourth reflecting estimate in centimeters, measure in centimeters, and positive differences in the last column. You are supposed to estimate the length of the pen in the first case and fill up the values in the 3 columns given here. Likewise, find out the length of an eraser, estimate its length, measurement in centimeters and positive difference. Then length of your palm, estimate in centimeters, write down the measure in centimeters and calculate the difference which is positive. Then length of your geometry box, estimate in centimeters, measure in centimeters and calculate the positive difference. Length of your maths notebook, estimate in centimeters, measure in centimeters and then find out the positive difference. Question number 10. Aditi likes solving puzzles. She recently started attempting the easy level Sudoku puzzles. The time she took in seconds to solve these puzzles are 410, 400, 370, 340, 360, 400, 320, 330, 310, 320, 290, 380, 280, 270, 230, 220 and 240. The first 9 values correspond to week 1 and the rest to week 2. A. Construct a dot plot given showing the data for both weeks. B. Describe the mean, median and any observation you may have about the data. We can also find the picture of Aditi here. She is solving puzzles. You are supposed to complete this dot plot in the graph given here. Question number 11. Individual project. Pick at least one of the following. A. How long is a sentence? Pick any 2 textbooks from different subjects. Choose any page with a lot of text from each book. First, use a dot plot to describe how many words the sentences have on each page. Second, compare the data of both the pages using mean and median. B. What is in a name? Write down the names of all of your classmates. The following are some interesting things you may do with this data. First, find the mean and median name length, number of letters in a name. Second, visualize the data and describe the variability and central tendency. Page number 133. Third, which starting letters are more popular? Which are less popular? Fourth, what is the median starting letter? What does this say about the number of names starting with the letters A, M, and N, Z? Fifth, plot a double bar graph depicting the number of boys' names and girls' names that start and end with vowels. Next, start with vowels and end with consonants. Next, start with consonants and end with vowels. Next, start and end with consonants. Question number 12. Individual project long term. This requires collecting data over 2 weeks or more. In and out. Track how many times you step out of your house in a day. Do this for a month. First, describe the variability and central tendency of this data. Make a dot plot. Second, do you find anything interesting about this data? Share your observations. Third, you can ask any of your family members or friends to do this as well. Question number 13. Small group project. Pick at least one of the following. Make groups of 8 to 10. Collect data individually as needed. Put together everyone's data and do the appropriate analysis and visualization. A. Our heights versus our family's heights. Collect the heights of your family members. First, make the dot plot reflecting heights of just your family members. Describe its variability and central tendency. Second, make a double bar graph reflecting each student's height next to their family's mean height. Third, observe everyone's data and share your observations. B. Estimating time. Check the time and close your eyes. Open them when you think 1 minute has passed. No counting. Note down for how many seconds you opened your eyes. Collect this data for yourself and for your family members. Repeat this activity to estimate 3 minutes. First, make 2 dot plots for 1 minute and 3 minutes, reflecting estimates of just your family members. Page number 134. Second, mark these on the respective dot plots. Describe its variability and central tendency. Third, make a double bar graph representing each family's mean 1 minute estimate and mean 3 minute estimate. Fourth, observe everyone's data and share your observations. Summary. First point, dot plots help us check a quick glimpse of the variability of the data, minimum, maximum, range, and how data is clustered or spread out. Second point, the arithmetic mean is equal to sum of all values in the data divided by number of values in the data. Third point, the median is the number in the middle of any sorted data. If there are an even number of values, then the median is the average of the two middle numbers. Fourth point, We can describe and compare data in several ways, including by referring to the minimum, maximum, total, range, arithmetic mean, and median. Fifth point, we learned how to read and make clustered bar graphs. These graphs can be used to compare and visualize values across categories and across time. Sixth point, examining data can lead to new questions and directions to probe further. Page number 135. Puzzle time. Connect the dots. A number lock has a 3-digit code. Find the code using the hints given. We have a number lock here with 3 blank spaces, and we have some clues to the puzzle. 265. One digit is correct and well placed. In 036, nothing is correct. In 271, one digit is correct but wrongly placed. In the next clue, 064, one digit is correct but wrongly placed. In the next clue, we have 542, two digits are correct but wrongly placed. The kids are looking curious to solve this puzzle. Chapter 5 ends here.
Ganit Prakash, Part 2. You were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Prasoon Kumar. Assistance in production, Amarjeet Sarkar. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.